All right, we're going to get started. So hello everyone, good afternoon. Welcome to the WinSPC workshop on capturing data from a variety of data sources. I'm Brad Armstrong, I'll be your host for today. In this session, we're going to dive into several examples of using WinSPC devices to pull data from a variety of gauges, machines, and other production systems. Hopefully the built-in tools we'll show you here will shed some light on other types of data you could link to and monitor in WinSPC. Wanted to let you know, though, up front that due to the limited time scheduled for these workshops, we won't be able to cover every option that's available in the devices. This is more designed to introduce you to the standard device concepts and provide you some general guidance on the basic setup options. Also, with the large number of attendees here, everyone's been muted like before, but if you do have questions, please use the questions panel in your GoToMeeting window. It should be on the right side of your screen. And at the end of the workshop, we're going to try and answer as many of those as we can. If we don't get to it, we'll reach out to you with an email afterwards. All right, so I'm going to hand this over to Frank Tappan. He's going to be walking us through the steps to configure devices. Frank's a CQE, CQA, and Six Sigma Black Belt, and he's put together some real nice examples for our session today. Frank?
All right, thanks, Brad. Before we get started, I'd just like to ask everyone to take a quick poll in the GoToWebinar panel, as this will help us get a better understanding of your current comfort level using WinSPC devices. So we're going to activate that poll, and we'll give everybody a moment to respond, and then we'll get started.
All right, the poll is open. We appreciate any input, your choices there. We'll give you another 3 or 4 seconds to finish up. Looks like most people have voted, a few others just finishing up. Great, this is very valuable insight. Thanks everyone for responding to that. I'm going to close the poll now.
Good. Well, it looks like the majority of you do have some experience using devices, with Serial and Excel being the top two. For those of you who are unfamiliar with WinSPC devices, I want you to picture a device to be synonymous with a data source. So our goal is to be able to pull data from any source. We can pull data from serial gauges, such as a caliper or micrometer. We can connect to CMMs and vision systems. We can talk to your ERP or MES system. We can tap into PLCs and control systems. And we can also pull data from Excel and other text files. So a WinSPC device allows us to communicate with those various data sources. All right, let's walk through a few examples, and I think you'll get a better idea of what I'm talking about. And to start, I'm going to log into WinSPC as an administrator and bring up the administrator window. Now, the steps to configure WinSPC for data collection are very simple, and they start with first identifying what parts you're making and the variables you're testing for. So, for example, maybe you make bottles and you're testing for thickness and weight. Second, identifying how you're doing the testing. Are you using serial gauges, or are you connecting to a CMM? And third, linking your sources of data collection to the variables using a collection plan. I'm going to assume that you already know how to create parts, variables, and collection plans. However, if you do need a refresher on how to configure these, check out some of the online videos in our video tour section on our website, and that should help you. For now, let's jump right into creating a device. So to create a device, we start by clicking the New Device button on the toolbar, and we give it a name. We'll name ours Caliper. And then once we've named it, we double-click on it to open it for editing. Before we go any further, it's important to note that defining a device, no matter what source you're pulling data from, is basically the same process. You'll define the connection, test it by taking a reading, and then mask off the reading from any extraneous information that you don't need. So the first decision that we have to make is to identify the data source, and we do this by selecting a device type. Here, you see a list of all the different sources that we support. There's a serial device, which would include anything that you can plug into a COM RS-232 or some USB port type gauges, such as a caliper or micrometer. There's a text file, which is commonly used to pull data from CMMs and vision systems. The next two, DDE and OLE, are older technologies used to communicate with legacy applications. They've been replaced by OPC, which is the most common device used to talk to PLCs nowadays. We can pull data from any ODBC compliant database, which means we can share information with your ERP, MES, or LIMS systems. We can read from a Microsoft Excel file. And finally, WinSPC can access devices that are connected to your network through a valid IP address. All right, let's go back to the serial device. A serial connection, as you guys have already alluded to in our poll, is a very common data source. As I've said, pretty much any gauge you can plug into the computer's COM port, and some gauges that you can plug into the USB port are considered serial connections in WinSPC. Now, we can also connect to wireless gauges through virtual COM ports. To begin configuring this device, let's walk through the fields on the Connections tab. The default settings that you see here for baud rate, stop bits, etc., are the most common and will work with most gauges right out of the box. However, you may need to check with your gauge manufacturer just to confirm the correct settings. Instead of using an actual gauge, we're going to use a serial device simulator, which you see on the screen at this point here. And this particular simulator is connected to a virtual COM port 8. Next, we have a prompt string field. Most serial gauges use a button or a foot switch to trigger the readings and thus wouldn't need a prompt string. But in some cases, a prompt string is needed to signal the gauge to transmit data. If that were the case, you would enter it here. And the last field on this screen is the channel number. This is used to route the data to the correct variable in a collection plan. If you were using a multiplexer with 2 or more channels, you would use this field to identify which gauge, i.e. channel number, is transmitting the data. Let's move to the Reading tab. The Reading tab is used first to test the settings that we just configured and to get a sample value, which we're going to use in the final tab called Mask. So the first thing that we do in this window is press the button, Get Reading. This opens the connection from WinSPC to your gauge and is now waiting to receive a measurement. So now we go to the gauge and we press the Send button on the gauge and it sends a reading. And voila, we have a measurement. If we had gotten gobbledygook at this point, it would have meant that something was configured wrong in the previous tab and we'd go back and fix it. But since we didn't, we're ready to move on to the final tab, Mask. Here is where we identify the locations in the string that contain the information we want to capture. We start by first selecting whether we're isolating data or tag information. Let's use the default of data for now. And in order to separate out just the measurement that's found in the string, there are a few common methods we could use. The most popular being the field delimiter method. In this example, we're going to use the comma as our delimiter, and then click on the field between a set of commas that contains our measurement. Now, to test this mask and confirm that everything is working, we press the Test button and send another reading from our gauge. Notice that the measurement was separated from the rest of the string and appears in the data value field here. Another common method to mask our data is by physical location. Using the offset and length options, we can highlight just the data we want to capture. This is sometimes called the brute force approach to masking data, and as long as the measurement is always located in position, it works extremely well. Whichever method you choose, just make sure that you test it and confirm that you've isolated the measurement. Once we've done that, we press OK to save our work. The last thing that we have to do is link this device to a variable, and we do that within a collection plan. So let's go to a plan that we've already created, and we'll walk through the steps. The first thing we do is highlight the variable. We then select the device to associate with the variable, in this case our serial device, caliper, and then we click OK to save the connection. All right, now let's collect some data using this device. So we launch our data collection screen, open up a data entry window. And now using our virtual device, we're going to simulate sending data by pressing the send button. As you can see, measurements are appearing on the control chart in real time. Okay, well, a lot of our customers, and as you guys have attested as well in the poll earlier, also like to use Excel to manage their data. So let's walk through an example of building an Excel device. Just like before, we click on the New Device button, we give it a name, and then we double-click on it to edit. As we did with the serial device, the very first thing we do is choose the data source. Let's select Excel. Now, because we're dealing with files, you'll notice that the connection information is slightly different. Instead of COM ports and baud rates, we're dealing with files. So to start, we're going to press the Browse button to the right of Files to Read and find an Excel file. Alternatively, we could have selected the option Any File in this folder and processed all of the files found in that folder. Next, we choose what to do with the file once we're done reading it. We could simply close it, we could delete it, and we can move it to another folder. If you're using this file for anything else besides WinSPC, I'd strongly recommend that you either close or move the file to another location when you're done. And finally, there's an option to choose a specific worksheet within the Excel file, assuming that you have more than one. All right, once we've selected the file, we'll go to the Mask tab. The masking of data for an Excel device has been simplified by putting everything on this one tab. So on this tab, we get a reading and mask off the locations. We start by pressing the Get Reading button and read in our file. And notice that when we do that, there's a lot of useful information in this spreadsheet in addition to the measurements. There's a line number, there's a press number, there's lot numbers. We can capture all of this information and store that info in tags in WinSPC. To do so, we first need to identify the location of each field where it can be found in the spreadsheet. And we do that by adding locations using the plus sign. And we add them to the list. Since we're working with tags, we're going to toggle the location type from data to tag. We're going to give the location a meaningful name, say line number. And then finally, we're going to, well, let's set up a few of them here. All right, once we've created a few tag locations, now we're going to add a data location. Now, the final step in this masking process is to assign the appropriate cells or columns in our Excel file to the appropriate location entries. To do so, we simply select the location in our list and then click on the specific cell or column to associate it with. Notice that the start and end row field numbers are being updated. For tags, we pick a specific cell. For data, we select an entire column. Now, in cases where we don't know how many rows are in our spreadsheet, we're going to use the asterisks to represent the end of file. One unique option that we have with data is the process field located here on the right. This field tells WinSPC to either read the entire file or just process new data that's been added to the spreadsheet since the last time the file was read. This works great where operators are using the Excel spreadsheet to collect data and they just keep appending their results to the end of the spreadsheet. When we're ready, we press the Test button to verify that everything is being sent to the correct locations. Everything looks good, so we're going to click OK and save our work. Now let's go to a collection plan and we're going to link to this device. And just like before, we're going to highlight each of our variables. We're going to select the device. And then in this case, we're going to choose the appropriate location for each variable. And once we've configured our variables, then we'll go to the Tag tab to assign our tags. Here we highlight the tags, select the device, just like we do with variables, and choose the appropriate location for tags. The final activity that we need to discuss is how do I trigger this device to collect data? Unlike serial gauges that come with a send button that I can just press and take a reading, we need to define a hotkey that whenever I press this hotkey will go out and read the Excel file. And we configure that hotkey on the Collection Plan Options tab. And here what we're going to do is select the prompt current device and choose a keystroke combination, say F10. Now an alternative method that we could have employed is to prompt this device is using the time data collection feature. So on this particular tab, we can actually set specific time intervals, say every 15 minutes, or actual time, say 1 o'clock or 2 o'clock, to read the spreadsheet. For this particular example, we're going to stick to the F10 hotkey. So let's save our changes, and we'll go to a data entry screen again and test our Excel device. So we launch data collection. And now at this point, we're pressing the function key F10, and when we do so, it goes out, reads the Excel spreadsheet, processes all of the data that it finds in that spreadsheet, and then brings up the control chart or updates the control chart. Now, when we drill into one of these subgroups here, just to show you, you'll see that the tag information was also captured with that reading.
I was just going to point out that right click that we're using from the collection plan is just a shortcut to data collection instead of going through the navigator screen.
All right, that's something related to Excel files or text files. Let's talk about text files here. Some gauges, and machines for that matter, output their data to text. And this would include many different vision systems and CMMs, like AVC, iPro, Sightline, Brown and Sharp, PC Demus, Sheffield, Zeiss, just to name a few. They output their data and store it in a text file. Now to create a text device, we start by clicking the New Device button, giving it a name, double-clicking on it to edit. And just like we did with the Excel file, the first thing we need to do is identify the data source. In this case, we're going to choose text. And then we click on the Browse button to find a text file. We can use any file that contains plain text information, and usually they're denoted with an extension like .txt or .csv, SCA, RTL. Those are a few common ones. We could choose to process more than one file. And finally, we need to let WinSPC know what to do once we're finished reading the file. Do we want to move it, close it, or delete it? Now let's go to the Reading tab, and we're going to test our connection by pressing the button Get Reading. The file in its entirety is read and displayed in the window above. And if our file contains header information, which it looks like it does here, we have the option to separate the two by choosing header and body. When we make this selection, you'll see the screen highlights change colors, denoting which area is the body and which area is the header, and then we can adjust the header length by making an entry down here. All right, just like the Excel device, we're going to start by masking off some of the tags that are found in the header. Again, to add a field, we click on the plus sign, toggle its type from data to tag, and rename it. We're going to use quotation marks for our delimiter here, since I can see that all the fields are separated by quotation marks. Now let's switch to the Body tab, and we're going to repeat the masking. Here I'm going to add a location with the plus button, leave its type to data, and rename it. And I'm also going to select the quotation mark as my delimiter and click on the measurement field. So when I'm done configuring these fields, I'm going to press the test button and confirm that everything is working. And good, it looks like we've isolated our tag, isolated our measurement. We're now going to click OK to save this device. Now the final step, as always, is to link the device and the specific locations to variables and tags in a collection plan. Since this particular device is very similar to an Excel file, I'm just going to assume that you already understand how to do that. We're going to move on to the next device. The next one that I want to talk about is connecting to a database like MS SQL or Oracle or Access. We can read from any ODBC compliant database using an ODBC device. And there's some examples of systems that use databases that you might have would include ERP, MRP systems, MES, SCADA, even LIMS. They all store their information in a relational database, usually an ODBC compliant database. So we're going to create a device, name it, edit it. And in this example, we're going to set the device type to ODBC. And now the simplest and easiest way to configure ODBC devices is to use the drop-down menu selections. All we have to do is select the database and then move to the first ODBC settings tab and choose a table within that database where our data resides. Technically, this is the minimum that's required to configure the device, but you might want to do just a little bit more, especially if you want to filter and sort your data before you pass it to WinSPC. If you do, you'll need to define a few more entries. For those who are familiar with writing SQL select statements, you could enter a statement here and use that to sort, select, and pull just the data that you're interested in. For everyone else, like myself, we're going to go to the second ODBC settings tab, and here, using drop-down menus, we can set our own filtering criteria. Walking through some of these fields, we have a data field, which we use to preview some of the data values that will be collected by this device. But since we're going to assign those in the collection plan, we're going to ignore that for now. There's a date-time selection, which will assign the date and time that is stored in your database to each of the measurements and store them on the measurements in WinSPC's date and time field. There's an ordering field, which can sort the data into a particular order. There's a channel number field, which you can use to filter your data and restrict what information is being read. And there's a sequence field, which is used to help WinSPC remember which database records have already been processed. Now, just a word of caution here. If you do not define a sequence number field, WinSPC potentially will reread the data that it finds in your database each time the device is prompted, and possibly collect the same readings over and over and over. So it's probably a good idea to choose a sequence number field when you're defining this device. For this example, we're going to use a really small database, so we're going to ignore that field. Now we're going to save our changes, and we're going to go to a collection plan and attach this device to a variable. So within the plan, we choose diameter as our variable. We select its data source to be the ODBC device. And then within the diameter or the field, we're going to select within that table. All right, now in this particular example here, we're going to save it once we've made that link. We're going to do the shortcut, as Brad mentioned, right-click and jump into a data collection screen. And fortunately, the F10 hotkey that we set up earlier is still active. So what we're going to do now is press that function key, F10. And when we do, it says read the entire database, grab that information, and plot it on a WinSPC control chart. All right, a fifth device is a network device type. The configuration for this particular device is very similar to serial gauges, and instead of walking through the entire setup from scratch, let's just take a look at one that we've already configured. The main difference between a network device and a serial device is on this connection tab right here. Instead of providing a COM port and a serial settings, we're looking for network connections or settings. So starting with the target type. The target type field specifies if we're using an IP address or a host name to locate the gauge on the network. And then depending on that setting, under IP address or host name, we'll actually specify the IP address or host name. The port is the TCP port number that the communication will occur between the WinSPC and the gauge. There's no, or masking and configuring the device is identical as a serial device. So there's no difference between this other than the connection field. So we're just going to save this device. We're not going to demonstrate this particular example just because it is identical to a serial device. The last device that we're going to discuss today are OPC devices. And OPC which was originally an acronym for OLE for process control, stands for Open Platform Communications. It's a standard protocol used to exchange real-time manufacturing production data between different systems. And the OPC standard has become very popular in many control systems such as Allen Bradley, Iconics, Wonderware, and many others have adopted its protocol. Through OPC, it's possible to track characteristics of your manufacturing process, such as temperatures, pressures, line speeds. In WinSPC acts as an OPC client and can communicate to any OPC server. It's the server that's continually scanning for data and then transmits any new readings it finds to the WinSPC client. So to configure this connection, we need first to identify the OPC server. And we're going to open up a device and click on the Browse button. And when we do, WinSPC will show us any active OPC servers that it can see on our network. And we're going to select one. There's no masking involved for this particular device. We simply save it, and then we go to a collection plan. And let's do that. And let's open up a collection plan. And what we're going to do is, for one of our variables, we're going to select the OPC device and an item from the OPC list. So when we click on that list, it displays all of the items that this particular OPC server is monitoring right now in real time. We're going to pick sign as just a demonstration. And in this particular case, we're going to use the time data collection feature that we talked about earlier. So we're going to set our time interval to be 1 second. And what that means is that every second we're going to connect to the OPC server, and if there's a new reading or a new value, it's going to transmit it to WinSPC. All right, we click OK, save it. We're going to launch into a data collection screen. Because we're connected to a live server, there's no prompting required. What happens is the moment that you open the data entry window, it will instantly start communicating and pulling data from that source. All right, by now you should see that there's a pattern used with all of these devices. You choose a device type, you define the connection details, you test the connection, and then you mask off just the data, isolating just the information that you want to send to WinSPC. Our ultimate goal here is to collect data from anywhere. With devices, we can pull data from virtually any CMM, vision system, PLCs, Excel, serial devices, text files. And if you happen to have a special piece of equipment that you're not able to connect to through one of these sources, we can write custom drivers just for you. The easier that we can make an operator's job by automating data collection, the better information you will have about your processes and the better quality products your company is going to be able to produce. My advice to you at this point is to jump in with both feet, attempt to make a device on your own, collect some data. You may want to do this first with a test part and a variable that once you've configured it and tested it, you can then migrate the device over to a live part. The help system within WinSPC will give you more information, and as always, you can contact our tech support group if you have any questions. Speaking of questions, let me take a few minutes now to answer any that you may have. For those that don't wish to stay around for the Q&A portion, I want to thank you for taking the time out of your busy schedule and participating in today's workshop. We plan to offer more of these workshops every 2 or 3 months or so, so please be on the lookout for the next event. All right, well, I'm going to take a few questions here. I'm just going to point them out. I see the first question here is, how do I determine which COM port my serial gauges are connected to or attached to? That's a very good question. What you're going to do is you're going to use the Windows, and I see Brad is bringing it up right now. So you're going to use the Windows Device Manager, and here we have, we just have a virtual one connected, but if I open it up, you can see that it tells me that I'm using COM port 8. If you had actual devices plugged in, you could pull this up and it would reference what COM port those devices are plugged into. How do we configure a wireless device that uses Bluetooth? The configuration for a wireless device is virtually the same as it is for a serial connection. With Bluetooth, you'll be connected to the computer. It's going to create a virtual COM port, and you're going to configure it as a serial device. What happens if we do not move a file after WinSPC reads it? Will it read it again? The answer is yes. If you're setting up an Excel file device or a text file device and you don't do anything, in other words, you don't move it, you don't delete it, you just leave it, you just close it, you've in essence left the file in the same location. The very next time that device is prompted, it will read that file a second time. So one of the questions here I see is I'm looking to connect our Renishaw equator to WinSPC, and the native output of the equator is a .res file. And the question is, can WinSPC accept that file? If that file is a plain text file, then the answer is yes. And I believe it is. I know I've used .res files in the past when I've demonstrated the software to other customers of ours. Can I process a .csv file using an Excel device? Yes. Yeah, that's a good question. So when you open it up in Excel, because Excel by default uses the comma delimiters to separate the fields into columns. So you could use an Excel device for a CSV file. Does the network IP device have to be on the same router where you can see the data port? I'm going to let Keith jump in here. He's our technical manager. I'll let him answer that question.
For that question, as long as WinSPC can get to that IP address, it can collect data from it. So it doesn't have to be necessarily on the same router, but it has to be routable. So as long as your routers are configured so you can get from point A to point B, you should be fine.
One more real quick. It says, I have a USB device. Do I have to set up a serial device type in WinSPC to connect to it? Not necessarily. So there are some USB devices that when you plug them in, they act as a keyboard wedge. And what that basically means is that wherever the cursor is, whatever field the cursor is currently on, when you press the button on your gauge, it automatically transmits the data to that field, just as if you had typed it in on the keyboard. So with USB devices, you don't always have to set up a serial device. You might want to check with your gauge manufacturer to see what you have. How do we capture only one data, I'm assuming measurement, in an hour from an OPC that generates 1 per second? That's where you would use the time data collection feature that we demonstrated at the very end there. So although we set ours to 1 per second, we could set ours to be 1 per hour. And what will happen is once per hour, we will go out to the OPC server and pull in just one reading. So that would be the easiest way to set and configure that up. One of the questions was, are we posting this session online, or this training session? Yes, yeah, all of the webinars or workshops that we are currently hosting this year, we're saving this session and we will be posting it online. Usually it takes us 24, 48 hours after we've completed it to package it and get it up there. But if you go to our website under video tours, I see Brad's got it up right now, you'll see some of the past workshops that we've already posted. Just a reminder, if you have any specific device questions, as always, tech support would be happy to assist you. Please give them a phone call. Their phone number is 248-447-0140. And it's a shame that I know that number more than my home phone number, but I call them routinely myself. So if you have any questions whatsoever, please reach out to our tech support staff. All right, any other questions that we have for today? Oh, okay. I'm getting we need to wrap up here. We do have a few more questions that we didn't get to, and what we're going to do is we're going to follow up with a direct email to everyone and respond to you. So if you did ask a question and we didn't get to it, unfortunately, we've got to wrap up because of time. I promise you we'll do that. Again, I want to thank everybody for attending today's workshop. I'm going to sign off. Brad, would you like to say anything?
No, thanks everyone. We'll talk to you again.
All right, take care, guys. I appreciate it. And like I said, we'll talk to you soon. I believe at the end there is going to be a quick survey, which will give us an idea of other topics you'd like to see in the future. Please fill out that survey or devices, and we'll work towards that. Have a good day.